I'd like to give a little background on myself. I have a computer science education and software development background, which in the last 20 years has been primarily devoted to supply chain management applications. This came about through collaboration with my husband, Professor David Simchi-Levi of MIT, who is a well-known supply chain expert. Our collaboration has been both on the business side as well as some very well-received publications, including the textbook, Designing and Managing the Supply Chain. In our first company, Logic Tools, we developed software for network design, inventory optimization, and related applications. The company was sold to iLog in 2007 and is now part of IBM Business Analytics Solutions. Our software has been used by over 350 companies and by over 50% of the AMR Gartner Top 50. Currently, I am the VP Operations of our second venture, OpsRules, a consulting company focused on analytics and optimization. Our goal is to help companies identify and capture hidden opportunities in their supply chains and operating models by becoming more data-driven. Many of the ideas are based on David's recent book, Operations Rules, which highlights the scientific rules of how the supply chains work, as well as a new approach to crucial operations topics such as complexity, risk, and flexibility. The second question, what are some of the main causes of imperfect data in supply chain analytics? In the operations area, many strides have been made to consolidate master data through enterprise resource planning systems, allowing for a single source of truth and providing more real-time updates. But companies still struggle with serious data quality issues. This is one of the most common things we see, and this is true across many industries. The three major symptoms that we see are, first, the inconsistency, different results depending on who you ask about the source of the data, the timing you're pulling the data, and the source of the data extract. That is why the mantra of single source of truth is so crucial. The second is inaccessibility. While it may be easy to identify the source of your data, can you actually use the data and sample it whenever you need it? It is of no benefit to your business to have good, clean data if it is locked up in a vault with no means of access, or if you have to jump through hoops to access it. To become data-driven, master and transactional data should be easily accessible to a wide base of users who can gain value out of the information. Third is incompleteness. Imagine you have found the right source of data and you have access to it. There's often a moment of truth when you start analyzing and reviewing the data and you find that what's supposed to be there isn't there. Master and transactional data sets with large chunks missing are almost as worthless as no data at all. So what do you do when you're faced with imperfect data? Our approach is that you're already making important operations decisions, and they will definitely improve if they are more data-driven. Therefore, alongside projects to improve data quality, you should use what you have and at the same time gain better understanding of the gaps. We will provide some examples from the area we are most familiar with, end-to-end optimization. In order to do this kind of analysis, network design, supplier risk, or inventory optimization, you need data on all your network as well as external information on customers and suppliers. The internal data includes information on products, plants, warehouses, and stores, including various cost capacities, bills of material, inventory levels, service times, and transportation. No company has all this data in one place, and there will be inevitable inconsistencies between different parts of the company, different facilities, etc. Based on our quite extensive experience with this type of modeling, we make 7 observations. The first one is that the process of collecting data will provide quite a lot of insight into how the company works and where there are performance issues. Several years ago, we worked with a paint company that was about to close one of its plants because it was old and inefficient. After they collected data about its production line cost and performance, which did not exist before in one place, and setting up the model and running optimization scenarios, they surprisingly decided to expand this plant for certain paints where it was more efficient than other more modern plants. The second observation is that missing or inaccurate data can be an issue, but some of it can be estimated based on similar data, and some of it ignored as too small to be meaningful. An example of missing data could be weight of a product which is required for transportation calculations. In many cases, the missing information is related to low-volume products which can be ignored or estimated without affecting the result. For the few important parts, it is important to find the right information. The third observation is that an important part of the process is building the baseline and validating it relative to the company's overall financial data. This process provides insight into where there are discrepancies in company data and how large they are, in effect providing a measure of the data problems. This is invaluable information as companies may not be aware of this, and it can provide the additional benefit of a way to prioritize where to tackle data issues. The fourth observation is that end-to-end optimization helps companies understand the drivers of cost. Even if the data is not perfect, it can help them see the direction of where they should be focusing their investment efforts. They can also run different scenarios based on different assumptions to analyze the impact of changes or even data quality. Can you trust these results? As long as they are consistent with intuition and experience, or if not, the difference between these two is understood, it is very likely much better than having no way to evaluate decisions. The fifth observation is that consider that most planning analysis is for the future supply chain. The demand forecast data is not all that accurate. Many costs could change over time and other factors may not be considered. Therefore, the rest of the data does not need to be perfect, just close enough to help make meaningful decisions. The sixth observation is that an end-to-end model enables analysis of various risks in the supply chain. You can systematically explore what happens if a facility is down and how much time you have to recover before you lose money. The data you need for this does not need to be completely accurate, but enough to provide the ability to spot trouble areas in the supply chain. And the final observation, the seventh, is that not all data is all that critical to the decision. There is a phenomenon in optimization that the result is flat around the optimum. This means that there are a range of options with similar cost results, not just one perfect optimized solution. Therefore, the model is not necessarily sensitive to all the data. Sensitivity analysis through different scenarios will help the modeler decide how much data is enough data. Final question, when is it okay to work with imperfect data? It is interesting to take a step back from supply chain analytics and see what is going with big data analytics, which is gaining a lot of traction and attention. In this space, data-driven decision making is all the rage, with the wide range availability of big data from the internet and analytics methods to glean better results, predictions, and recommendations. But one of the challenges is still matching the data available to the one needed for the analytics. A recent New York Times article titled "For Big Data Scientists Hurdle to Insight is Janitor Work" this article noted that data scientists, according to interviews and expert estimates, spend from 50% to 80% of their time mired in the mundane labor of collecting and preparing unruly digital data before it can be explored for useful nudges. And this is definitely our experience as well with the kind of projects we do. Our approach is that you're already making important decisions, and they will definitely improve if they are more data-driven. Therefore, alongside projects to improve data quality, you should use what you have and at the same time gain better understanding of the gaps. The New York Times article also mentioned that data scientists emphasize that there will always be some hands-on work in data preparation, and there should be. Data science, they say, is a step-by-step process of experimentation. And then they mentioned that this type of work is called data wrangling. In real life, you're going to work with bad quality data. The data is not only imperfect, but you also need to understand how to use the data and the analytics. So you can't wait for perfect data, but you need to start experimenting with supply chain analytics as soon as you can. A final quote from the article in the New York Times of Professor Jeffrey: "It's an absolute myth that you can send an algorithm over raw data and have insights pop up.